All right. So everyone knows Vega, right? I mean, it's that really bright star. You can practically see it from Times Square.
Right.
But it turns out Vega has this kind of secret. And it's a secret that has astronomers totally baffled.
Yeah.
So we're diving deep today into all the latest intel, like from Hubble and the James Webb Space Telescope.
Nice.
We've got press releases. We've got scientific papers.
Wow, the whole 9 yards?
Yeah, to try and unravel this cosmic enigma.
Sounds fun.
So buckle up, because what we're about to uncover, I think, is going to make you rethink pretty much everything you thought you knew about how planets form.
All right, so what's so fascinating about Vega is that it has this colossal disk of dust and gas that's just swirling around it. And we're talking like a mind-boggling 100 billion miles wide.
Oh, wow.
So just imagine this cosmic construction site with enough raw material to build countless planets.
Right, you'd think with all those building blocks just kind of scattered around, planet formation would be a piece of cake.
Right.
But there's a twist, and this is where it gets really wild.
Okay.
Vega's disk is, like, incredibly smooth, like suspiciously smooth. We're not seeing those telltale signs of planets, you know, carving out paths through the dust, those cosmic snowplows that we typically observe around young stars. It's like the planets just skip town.
Yeah, exactly. It's throwing a massive wrench into our traditional understanding of planet formation, you know.
Like, what's going on here?
Yeah, like that classic story where stars form from these giant clouds of gas and dust.
Right.
And they leave behind this messy disk of leftovers, and then eventually they clump together to form planets.
Yeah.
Vega seems to be saying, nah, not in my backyard.
So what's happening here? Did the planets just, like, miss the memo? Or is there something even more profound happening?
Well, let's take a closer look.
Okay.
What we're discovering is that the dust distribution in Vega's disk, it isn't just random. It's actually layered. So the smaller particles are being pushed further out by the pressure of starlight.
Oh, that's interesting.
Yeah, it's like a cosmic sorting machine.
Wow.
Where the starlight acts as the ultimate organizer, and this tells us a lot about the forces at play.
Hold on, you're telling me starlight can actually push stuff around?
Yeah.
I thought it was just light.
It is amazing, isn't it? We often think of starlight as this gentle, illuminating force.
Right.
But it carries momentum.
Really?
And it can exert a real push, especially on tiny dust particles.
Huh.
And in the vastness of space over millions of years, that push can sculpt entire planetary systems.
Okay, mind officially blown.
It's pretty cool.
So no signs of any massive planets in those wider orbits, at least not any that our current tech can detect. But that doesn't rule out smaller planets huddled closer to the star.
Yeah, that's certainly a possibility.
Okay.
But the real puzzle is why Vega's system seems to be playing by a different set of rules compared to other systems that we've observed.
Right.
It's like finding a cake perfectly baked without any of the usual ingredients. Like, how did it even happen?
Yeah, what's going on there?
It's like we have this cosmic recipe book, you know, for planet formation.
Right.
And we thought we had it all figured out. But then Vega comes along and tosses the book right out the window.
Oh, wow.
And shows us that there might be entirely different pathways to creating planetary systems that we haven't even considered.
Okay. So let's get down to, like, the nitty-gritty.
Okay.
What exactly are we seeing in Vega's disk?
Right.
You mentioned layered dust.
Yeah.
Tell me more about that.
So imagine you're sifting flour for a cake. And you have, like, a fine mesh sieve that lets the smallest particles through.
Yeah.
And a coarser sieve that catches the larger bits.
Okay.
Vega's starlight is kind of acting like that sieve.
Huh.
So it's sorting the dust particles by size.
Gotcha.
The finer dust,
Yeah.
like those tiny flour particles, gets pushed further out by the starlight, while the heavier, coarser particles remain closer in. And it's creating this intricate, layered structure within the disk.
So it's not just like a smooth, featureless disk.
Right.
There's actually, like, a lot going on beneath the surface.
Absolutely. And by studying these different layers, we can piece together a more detailed picture of how the disk is evolving.
Okay.
And what forces are shaping it.
Yeah.
Think of it like reading a cosmic fingerprint, where each dust particle tells a story about the dynamics of the system.
All right, so we've got starlight acting as this cosmic sorter,
Right.
creating these distinct layers of dust. But let's circle back to, like, the elephant in the room, or rather the lack of an elephant in the room.
Right.
Where are the planets?
The missing planets.
Yeah.
Now, just because we haven't found any large planets in those wider orbits doesn't mean they aren't there.
Okay.
They could be smaller planets, maybe closer in,
right,
hugging the star where they're harder to spot. Or perhaps they formed early on and then migrated outwards, leaving behind that smooth, undisturbed disk.
Okay, so maybe the planets are just playing like hide and seek with us. But if we can't see them directly, how can we even begin to test these theories?
That's where the real detective work comes in.
Okay.
We need to look for subtle clues.
Yeah.
Hidden within the disk itself. For example, variations in the dust density or temperature could hint at the presence of unseen planets.
So like faint footprints left behind in the cosmic sand.
Exactly. Even if we can't see the planets directly, we can search for their gravitational fingerprints imprinted on the disk.
Fascinating. So is it possible that we're just like looking in the wrong place? Maybe Vega's planets formed in a different way or ended up somewhere we haven't even thought to look yet?
That's another intriguing possibility. Our understanding of planet formation is constantly evolving.
Right.
We used to think it was a relatively straightforward process. But Vegas is challenging that assumption.
Right.
Maybe there are entirely different pathways to forming planets that we're only just beginning to grasp.
You know, it's kind of humbling, isn't it?
Right.
We thought we had this whole planet-making thing figured out, and then along comes Vega, this seemingly ordinary star, to just shake things up.
It's a great reminder that the universe is full of surprises.
Yeah.
And that our knowledge is always evolving.
Right.
There's so much more to learn. And that's what makes exploring these cosmic mysteries so exciting.
Speaking of cosmic mysteries you mentioned earlier, that Vega system seems to be an outlier compared to other systems that we've observed. But there's another star, Fomalhaut, that's similar to Vega in age, distance, and temperature, right?
Yes. Fomalhaut is a fascinating comparison.
Okay.
It's like having two cosmic siblings.
Oh, wow.
Raised in the same stellar nursery, yet they've taken completely different paths.
Okay, I'm hooked. What's the story with Fomalhaut?
Well, unlike Vega's smooth disk,
Yeah.
Fomalhaut has these striking rings of dust and debris encircling it.
Oh, wow.
And scientists believe these rings are sculpted by unseen planets.
Really?
Their gravity is shepherding the dust into those distinct patterns.
Wait, so Fomalhaut has these dramatic planet-carved rings, while Vega's disk is as smooth as a freshly Zambonied ice rink.
Exactly. It's a stark contrast.
Wow.
And it raises some big questions.
Yeah, like what?
Why are these two systems so different?
Right.
What factors tip the scales in favor of planet formation around Fomalhaut? Well, Vega seemingly missed the memo.
You know, it's like having two seemingly identical twins raised in the same environment.
Right.
Yet one becomes a world-class athlete, while the other excels as a concert pianist. There's clearly something more at play than just their shared upbringing.
Precisely. It suggests that there might be subtle differences in the initial conditions of the protoplanetary disks.
Right.
Those swirling clouds of gas and dust that gave birth to the stars and planets.
Yeah.
Or perhaps external events, like close encounters with other stars.
Okay.
Nudged these systems along different evolutionary paths.
So it could be a combination of nature and nurture, cosmically speaking?
Exactly.
And each system holds clues to a different piece of the planet formation puzzle.
Exactly. And that's why studying both systems, like Vega and Fomalhaut, is so crucial. They're like two sides of the same cosmic coin.
Right.
Helping us piece together a more complete picture of how planets form and evolve.
Okay, but let's get back to Vega for a second.
Okay.
You mentioned earlier that maybe its planets formed differently or ended up in some unexpected location.
Yeah.
What are some of like the wilder possibilities that astronomers are considering?
Well, one intriguing idea is that perhaps the planets around Vega formed much earlier than we typically expect. Gobble up all the available dust and gas in the process.
Oh, wow.
And then over billions of years, they migrated outwards, leaving behind that pristine, smooth disk.
So like cosmic pioneers venturing out to the galactic frontier.
Exactly. It's a fascinating scenario.
Yeah.
And it would explain why we don't see any planets in those wider orbits today.
But wouldn't those early forming planets have left some kind of trace behind, like some subtle signs of their existence in the disk?
You'd think so, but remember, the disk itself is constantly evolving.
Okay.
Over billions of years.
Yeah.
Those early planet-forming events could have been smoothed over, like footprints fading in the sand.
Okay, so it's like a cosmic cold case.
Right.
With clues scattered across billions of years.
Precisely, and that's the challenge.
Yeah.
And the thrill of studying these ancient systems.
Right.
We have to piece together a puzzle where some of the pieces might be missing or have changed beyond recognition.
All right, so we've explored the possibility of early forming migrating planets.
Right.
What other scenarios are on the table?
Another idea is that perhaps Vega's disk was disrupted by a close encounter with another star.
Oh.
These kinds of interactions can be quite dramatic.
Wow.
Stirring up the disk and potentially scattering planets out of the system altogether.
Like a cosmic game of billiards with stars as the cue balls.
Exactly. It's a chaotic process.
Wow.
And it could explain why Vega's system looks so different compared to its more orderly sibling Fomalhaut.
So it's possible that Vega's planets didn't just disappear.
Right.
They were evicted from the system altogether.
That's one possibility.
Huh.
Or maybe they were pushed into highly eccentric orbits, making them incredibly difficult to detect.
Okay, so we've got missing planets, migrating planets, ejected planets.
Right.
It's starting to sound like a cosmic mystery novel, but how can we tell which of these scenarios is like the most likely?
That's where future observations come in.
Okay.
With more powerful telescopes and sophisticated modeling techniques, we can continue to scrutinize Vega's disk, searching for those telltale signs that'll unlock its secrets.
You know, it's pretty mind-blowing to think that a star as seemingly ordinary as Vega can hold such profound mysteries and challenge our understanding of planet formation so dramatically.
It's a testament to the incredible diversity and complexity of the universe.
Right.
And it's a reminder that even seemingly simple observations can lead to groundbreaking discoveries.
All right, so we've dived deep into the mystery of Vega's smooth disk, exploring the possibilities of missing planets, migrating planets, and even cosmic evictions.
Right.
But before we wrap up our deep dive, let's take a step back and consider like the historical significance of this star. You mentioned earlier that Vega was actually the first star around which we ever detected a potential planet-forming disk.
That's right, back in 1984.
Wow.
The Infrared Astronomical Satellite, or IRAS, picked up this unusual excess of infrared light coming from Vega. It was a groundbreaking discovery.
Wow.
Suggesting the presence of warm dust around the star.
So IRAS gave us the first hints that there might be something interesting happening around Vega.
Right.
But back then, we didn't have the technology to see the disk in detail, right?
Exactly. It was like seeing a blurry photograph from a distance.
Right.
We knew something was there, but we couldn't make out the finer details.
And now, thanks to incredible instruments like Hubble and the James Webb Space Telescope, we can peer into Vega's disk with unprecedented clarity, revealing those intricate layers of dust and prompting us to rethink our models of planet formation.
It's a perfect example of how scientific progress builds upon itself. Each new generation of telescopes and instruments, pushing the boundaries of our knowledge further and further.
And it all started with Vega, this seemingly ordinary star that's now at the forefront of our quest to understand the origins of planetary systems.
It's a reminder that the universe is full of wonder and mystery. And that there's always more to learn, more to explore, more to discover.
All right, so we've journeyed from the early days of IRS to the cutting-edge observations of Hubble and Webb, uncovering the secrets of Vega's smooth disk and its implications for planet formation. But before we conclude our exploration, let's zoom out and consider the bigger picture. What does this smooth disk mystery tell us about the grand scheme of things, about the diversity of planetary systems across the cosmos? It's like we thought there was only one way to bake a cake, but Vega's showing us that there's like this whole cookbook out there full of different recipes and techniques.
Exactly. We used to think of planet formation as this relatively straightforward process. Cloud collapses, a disk forms, and boom, planets start popping up like daisies. But Vega's throwing us a curveball. Showing us that it's not a one-size-fits-all scenario. There could be this whole spectrum of planetary systems out there. Some with those giant planets carving up their disks. Others with these pristine, smooth disks like Vega and everything in between.
So our own solar system, with its neatly arranged planets and asteroid belt, might actually be the exception, not the rule.
It certainly seems that way.
Wow, that's kind of mind-blowing, isn't it?
It is. The more we explore, the more we realize just how diverse and complex planetary systems can be.
Right.
It's a humbling realization.
Yeah.
And it opens up a whole new realm of possibilities for what might be lurking out there.
Yeah.
In the vastness of space.
Okay, so we've established that Vega is really shaking up our understanding of planet formation. But there's this one, nagging question that keeps popping up.
Okay.
And I know you're probably thinking it too.
Right.
If planets didn't form around Vega, what happened to all that dust and gas?
Right. The million-dollar question.
Yeah.
And honestly, we don't have a definitive answer yet.
Okay.
It's a puzzle that astronomers are still trying to piece together.
Right.
It's possible that some of that material was absorbed by the star itself.
Okay.
Drawn in by its powerful gravity.
Right.
And some might have been blown away by stellar winds.
Oh.
Those streams of charged particles that stars constantly emit.
So imagine a cosmic leaf blower scattering the dust and gas across interstellar space.
Exactly. And then there's the possibility that some of that material's still out there.
Okay.
Lurking in the form of smaller undetected objects.
Huh.
Maybe even a population of rogue planets.
Rogue planets.
Yeah.
Now there's a thought that sends chills down my spine.
Yeah.
Imagine these planets just wandering alone through the darkness of interstellar space, no longer tethered to their parent star.
Right.
It's like a cosmic ghost story.
It's certainly a captivating image, isn't it?
Yeah.
And it highlights just how much we still have to learn about the universe. And the strange and wonderful ways in which planetary systems can form and evolve.
Okay, so we've got missing planets, migrating planets, ejected planets, and maybe even a population of these cosmic nomads wandering the galaxy. Vega's smooth disk has opened up a Pandora's box of possibilities.
It really has.
But ultimately, it seems like we're left with more questions than answers.
That's the beauty of science, isn't it?
Yeah.
It's a never-ending quest for knowledge.
Right.
A journey of exploration that's fueled by curiosity and wonder. Every answer we uncover often leads to more questions, pushing us to delve deeper, to refine our understanding, and to embrace the unknown.
It's funny. For centuries, Vega has captivated humanity with its brilliance inspiring countless myths and legends.
It's a beautiful star.
It is. And now, thanks to modern astronomy, it's revealing secrets that are even more captivating, challenging us to rethink our place in this vast cosmic tapestry.
It's a reminder that the universe is full of surprises.
Yeah.
That even the most seemingly ordinary objects can hold profound mysteries. Just waiting to be uncovered.
Well, I think it's safe to say that we've officially reached peak Vega.
I think so.
For one deep dive.
Yeah.
But before we sign off, I want to leave you with this thought.
Okay.
The next time you look up at Vega, twinkling in the night sky, remember that behind that brilliant facade lies a story that's still unfolding. A story of cosmic creation, evolution, and perhaps even a touch of cosmic mystery.
Keep looking up, keep asking questions, and never stop exploring the wonders of the universe.
Right.
Who knows what incredible discoveries await us?
Yeah.
It's beyond the horizon.